It is now time for lesson 4. We're looking at subatomic particles. Plain English, we're going to basically what is an atom, let's say, composed of. Again, this is going to be much a review, but it's crucial that we know what is inside of each element, or sorry, of each atom or element. And the more we know, the better we're going to understand something called, well, we have atoms, and then pretty soon we're going to move on to something called ions. So this is maybe basic, but very, very important. The student learning objectives: identify and quantify all particles, know the symbols and charges. I actually even added on here location. And then you have what are isotopes. I don't find this to be overly important right now in Science 10. I'll kind of just do an introduction to that and we'll move on. Again, if you find it helpful for now on, you might want to have your periodic table data booklet with you, just to kind of help you maybe check things out as we go. Now, I just want to take a moment and draw the model of the atom. And I apologize, my drawing is not so good, especially on this tablet. But remember, you had the nucleus. And inside of the nucleus, you had two types of particles. You had the positive protons, and you had the neutral neutrons. And then hopefully you remember the electrons are on the outside in a cloud or a shell. And please remember that they are in different energy levels. So this is the first one, there'd be a certain number, and then there could be more in a second energy level, and so on and so forth. But this was the quantum mechanical model that we accept today about the atom. This is, again, I would expect that this would be something that you know. This we can go through fairly briefly. This information is found on page 33 of your textbook. I'll just do this very briefly. The electrons, I hope that you know the symbol. What they always use is a lowercase e with a little minus sign, just to help you remember that it's negative, and of course the charge is negative. The mass. The mass is, very, very small. 9.1 times 10 to the minus 28 grams. That's going to be extremely small. And as you know, the location is going to be, let's just say, surrounding the nucleus. This is somewhat a summary. When you have the protons, I guess, and I'm guilty of not using the right one. Sometimes I just use a positive symbol, but I shouldn't do that. It is a lowercase p with a positive. The charge is positive, as we know. The protons they do have more mass than electrons. It's 1.7 times 10 to the minus 24 grams. And the location is going to be within the nucleus. Next, alongside the proton, you're going to have the neutron. The neutron, they actually use a lowercase o with an exponent or a charge symbol of 0, basically meaning there is no charge. The mass of the neutron is going to be the exact same as the proton, 1.7 times 10 to the minus 24 grams. And it also is within the nucleus. I would hope that these basic characteristics of the electron, proton, and neutron you would know. I would never expect someone to remember the mass of something. I don't want you to say, oh, it must be 1.7. No. That I don't care about. What I care about is that you know the symbols, you know the charge, you know where to find them, and you know how to draw an acceptable model of the atom. Finally, I did mention isotopes. I'm not going to spend too much time on them. Essentially, this kind of sounds odd, but what you can see right here, everybody, is different versions of carbon. Now, carbon you can find on your periodic table. Well, right here we have 3 different versions of it. And what you're going to notice is that in each of them, the number of protons and neutrons changes. And that, of course, as you can see, there's these different numbers. So when you have an isotope, it's atoms of the same element that contain different number of neutrons. You'll notice the number of protons is always the same. It's the number of neutrons that changes. Basically, this leads into something that it is valuable to know. I'd like you to know, maybe make a note of this, mass number. The mass number is equal to the protons plus neutrons. And you can see that in this example of the carbon right here. Now, if you want to figure out the number of neutrons specifically, because on the periodic table, it won't be given to you, there is something called the atomic molar mass. And if you want to see that example, it is on page 34 of your textbook. So I want you to be familiar with what isotopes are. I want you to know that the protons stay the same. It's just sometimes the number of neutrons changes. I would like you to be familiar with what the mass number means. And I would also like you to be familiar with how you use the atomic molar mass to determine the number of neutrons. And like I said, that's an example on page 34. If you read this page, you'll have a very good idea of what they're trying to get at. So, in this little mini lesson, we looked at kind of the particles that make up an atom. We looked at some differences of isotopes, why they're a little bit different, and some base calculations. I believe the textbook does a fairly good job of covering this as well if you want some more backup onto this. Quite simply, it's on pages 33 and 34. Anyway, I think we're ready to move on.